So we are going to hit our Foundation 2 live lesson. And in this lesson, we are going to be looking at relative frequency. Now, this comes quite late in the course, but don't worry. Everything that you need to know is something I'm going to be giving you in this lesson. All right. So let me share with you. All right. And then we can slideshow. And we make sure the pen is working. I'll keep it actually. All right. So we are going to be looking at relative frequency. Now, some of you may know what relative frequency is, and that's great. If you don't worry, we are going to be dealing with that in this. So let's have a look. Relative frequency is a measure of what proportion of the data falls into a particular class or class interval. All right. So you may have heard of relative frequency when it comes to probability. And you know in probability, there are specific outcomes of events. Those are going to be the particular classes or class intervals that we are looking at. So it is defined as the frequency of an event divided by the total number of data items. So it is how many times the event happened over the total amount of times that we ran this experiment. And that sounds kind of similar to probability, but at the very end, we're going to see how this differs. And it's important to remember this last point over here. The sum of relative frequencies of your data set sums to 1. It's a horrific box, but we can deal with it. So this relative frequency is the frequency of one of the events out of all of them that we have over the total amount. So you could imagine that if we were to do the relative frequency for all the events we are looking for, and you add those together, it should surely come to 1 because each frequency is added together to get the total amount of data. So if you have, for example, 3 events, so you've got, for example, event 1 has a frequency of 3, event 2 has a frequency of 5, and event 3 has a frequency of 1. Together, we can see that there are 9 results. There are 9 outcomes. How would we calculate the relative frequency of this? Well, the relative frequency of event 1 would be 3 out of 9 because it's the frequency of the event out of the total amount of data items. The relative frequency of this one would be 5 over 9, and the relative frequency of this one would be 1 over 9. Now, if you add all of them together, 3 plus 5 plus 1, 3 plus 5 is 8, plus 1 is 9, and we can just add the numerators because our denominators are the same. So that comes out all together at 9 over 9, and that's why it comes out as 1. So the sum will always be 1. So listing outcomes is a crucial part of this because without listing it and finding the frequency, you are unable to find your relative frequency. So you need to remember that to determine how many data values you have, that is what is going to be the denominator, which is what we saw on the previous slide. So you could be given a frequency table or even a tally table, something like this. And we must remember this over here, this is my tally side, and this over here, this is my frequency side. Now, tallies are the, let's say, the starting point for frequencies. And tallies, we know how to do tally markings, that it is simply vertical lines like that. And every time that you get one of these items that we're looking at, you just put another one. And we could just keep going, keep going, keep going. But this is far harder to calculate or count up than if we were to try and separate them somehow. So that's why you have this diagonal line, or sometimes the horizontal line as well. And every fifth one is a horizontal line. So we can go 1, 2, 3, 4. This one is not going to be there anymore. It's now going to be across those 4. 1, 2, 3, 4. This one is not going to be there anymore. It's now going to be across those. And now it's far easier to have a look at that. Even if I take out the scratching there, it is far easier to be able to count these, because now I literally just count in 5s. 5, 10, 12, done. Instead of counting, 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 and then your eyes might lose count of 1, you might add 1, you might miss 1. This is very, very simple. So here we can see that's a 5 plus a 2 makes a 7, and a 5 plus a 4 makes a 9. So if we wanted to calculate a relative frequency here, it would be 7 over the total, and 9 plus 7 is 16. And the relative frequency here would be 9 over the total, which is 16. And if you add all of them together, 7 over 16 plus 9 over 16 gives me 16 over 16. And 16 over 16 is 1. It's a useful check to make sure that you've counted all possible outcomes, as well as all the data that you've received. All right, so then we move on. So let's have a look at another example. A survey was conducted to investigate the number of animals that a family has in a particular suburb. Doesn't matter what suburb, you can choose the suburb. The data was used to draw up a frequency table. Now, you might be given, as I said, a tally side and a frequency side. You might only be given a tally side. You might only be given a frequency side. Most often, you will only be given the frequency side. So the amount of families that had no pets was 4. The amount of families that had 1 pet was 9. 2 pets is 5. 3 pets is 4. 4 pets is 3. 5 pets is 3. And more than 5 pets, those crazy people, there were only 2 families in the suburb that had that. And the question is, calculate the relative frequency of class 3. So how many families only had 3 pets? And I suppose that's not really an only statement, but there are more. So let's say, how many families had 3? Well, you move across, and you find out that there were 4 of them. So therefore, the relative frequency is the frequency of an event over the total number of data items. So it was 4 here over the total amount, and we can add that up. So 4 plus 9 is 13. 13 plus 5 is 18. 18 plus 4 is 22. 22 plus 3 is 25. 25 plus 3 is 28. And 28 plus 2 gives me my 30 total. This you could write as a decimal if you wanted as well. You could even simplify the fraction to become 2 over 15. That doesn't matter. Simplification is not a crucial issue in this section. You can see it's quite simple to do. You literally look at the number, take the total, and there you go. What about this example? A survey was conducted to investigate in which industries people work. So question has come through, what week are you going to do this in? So it is quite late in the course, as I said. Let me find it quickly for you. All right, so after checking, I found that it is indeed week 30, and it is lesson 76 at the moment. All right. So back to this, we have a group of 50 people. So this means that we do not need to sum up any values that have been given to us because they have given us the total already. So 50 people were asked to indicate in which industries they work. 11 people work in construction. 13 people work in medical. 12 people work in education. And 14 people work in transport. So the question says, what are the relative frequencies of the 4 classes mentioned above? Meaning calculate the relative frequencies for all 4 of them. And we need to show that the sum of all the relative frequencies adds up to approximately 1. Now, why would they say approximately? Well, this approximately only comes into effect when we write our fraction as decimals. Because when you write it as decimals, you're going to have to round off. And you might find that you might round off somehow through all of them, and when adding up, you might come to 0.99 or 1.01, for example. That's not because they actually add up to that. It's because through the rounding, you've created that problem. That's why for me, I always prefer fractions, 1, because they're exact, and 2, because you never have any of these issues. All right, so let's work out our relative frequencies. So just to help you out, I've written at the top what each of them are. So 11 of them were in the construction industry, 13 of them were in the medical industry, 12 of them in the education industry, and 14 of them were in the transport industry. And just in case you had forgotten, we could add these up. So 11 and 13 is 24. 24 and 12 is 36. And 36 plus 14 gives me my 50. That is my total. All right. So relative frequency for construction is simply the 11 of construction out of the total of 50. You can write that as 0.22. This is an exact decimal because of the denominator. Then for medical, it is my 13 medical people out of 50. And again, 0.26 is an exact decimal. All right. Next one, we do education. And education is my 12 people out of my 50, 0.24 as a decimal, that is exact as well. And then lastly, when it comes to transport, it is 14, because that's 14 people out of 50, 0.28 as a decimal. So we can add these up. So 11 plus 13, again, is 24, plus 12 is 36, plus 14 is 50. So that's 50 over 50, which gives 1. But also, as decimals, 0.22 plus 0.26 plus 0.24 plus 0.28 also gives me exactly 1. All right. All right, so no questions. So then we get to the final point. The difference between relative frequency and probability. So you've been dealing with probability a lot. Now, you may have realized what the difference is, or you may think that it's exactly the same thing. However, they're not the same thing. It's very important to remember they are similar, but they are most definitely not the same thing. So I've got a video to explain to you why it is not the same thing.
The difference between relative frequency and probability. Roger is sitting in his maths class at school on a Monday. His teacher tells the class that for homework, they need to go home and flip a coin 50 times. They must record how many times heads was facing upwards and how many times tails was facing upwards. When Roger arrives back at school on Tuesday, the teacher gives the same homework again, another 50 flips. The same happened on Wednesday and again on Thursday. On Friday, his maths teacher asked the class to draw a table to show how many heads and how many tails were recorded. Roger's results are shown in this table. On Monday, Roger flipped 31 heads facing upwards and 19 tails facing upwards. On Tuesday, 21 heads faced upwards and 29 tails faced upwards. On Wednesday, the coin landed 24 times with heads showing and 26 times with tails showing. And on Thursday, he flipped 26 heads facing upwards and 24 tails facing upwards. The teacher then asks for the probability of getting heads when flipping a coin. Roger answers proudly with his results of 51%, since 102 divided by 200 equals 51%. The teacher says that he is incorrect and that the correct answer is 50%. How can this be?
What Roger has told the teacher is the relative frequency. Relative frequency refers to the proportion of heads facing upwards out of the trials that he performed. The actual probability relates to the number of possible outcomes. Since there is one side that is heads and one side that is tails, the probability of getting heads facing upwards is 1 out of 2, which equals 50%. No matter how many trials are performed, the probability will never change. Also, the relative frequency will get closer and closer to the real probability with more trials. Perform more trials yourself to test this out.
All right. So there you can see that relative frequency measures something different than probability. Relative frequency looks at all the trials and experimentation that you are running and then takes a proportion out of that. Probability is completely independent of how many trials you run. It is purely dependent on what outcomes could occur, and then you look at that. So that's why the probability of getting heads when flipping a coin will always be a half, no matter what, of course, assuming a fair coin, whereas relative frequency will constantly change because it is taking into account the number of trials, but with more trials you do and more and more and more, it will eventually head towards your theoretical probability.